Okay, so this chapter is about what's called rational expressions. And we've seen that or those two words a lot in the chapter. We had, like I said, last semester we had chapter on quadratics, on polynomials, on radicals, right? So this one is about rational expressions. What are rational expressions? Well, two things. First thing, it's a fraction. Okay, it's a fraction. Second thing is it's an algebraic fraction. So what does an algebraic mean? Algebra just means when you see letters in math, right? You see letters in math. Anytime there's letters involved in math, A, B, X, Y, that's algebra. You're doing algebra, okay? So like the first problem, example number 1, A and B, those don't have any letters. Those are just numbers, right? So that's not algebra, okay? So that's all it means. Fractions who have letters. Algebraic fractions, okay? So we're just going to be simplifying them today. You guys have been doing this for a while, right? You guys learned how to simplify fractions, reduce fractions a long time ago. We're going to be doing that same thing, but they're going to look a little different than they used to. Okay, so let's start with some problems that you've seen before. So example number 1, A and B. We'll start with A. How do you reduce fractions? What's the process for reducing fractions? Like you guys have done that before in this class. What's the process you go through to reduce a fraction? Most of you can do this in your head. What is that process, though? How do you reduce a fraction? What do you need to do? You divide by the greatest common factor, right? The biggest number that goes into the top and the bottom. Most of you can do that in your head, like for A. What is the biggest number that goes into 12 and 15? 3, right? Most of you guys can do that in your head. Today, I'm going to kind of do it a different way because it's going to help you later. So this is what you do in your head, right? This is what you do. You break down 12. In your head, you break down 12, right? What do I mean by break down 12? I mean do one of these guys that we've done many, many times before, right? 4 times 3, 2 times 2. All right, so 12 is 2 times 2 times 3. Do the same thing for 15. What's the only way to use the only way for 15 to make 15 using multiplication is what? 5 and 3, right? That's it. And it doesn't break down anymore. So 5 times 3, right? Now, what number do they share on top and on bottom? What number do they share on top and on bottom? 3, which is the greatest common factor, right? So on top, we get 2 times 2 times 1, which is 4. On bottom, we get 5 times 1, which is 5. Fractions reduced. Okay. Now, I know a lot of you guys do that in your head, which is fine. No problems. The reason I'm doing it kind of the long way is because it's going to help you later. It's going to help you later. When we start seeing rational expressions, these steps will help you when we get there. Okay? So the same thing for 24. So the first thing we're going to do is find the biggest number that goes into both. Some of you can do it in your head. If you can't, this is how I tell students. If you can't do that in your head, use these steps. Break down 24. 8 times 3 or 12 times 2 or 6 times 4. So I circle the 3, 4 times 2, 2 times 2. Right? So 24 is 3 2s and a 3. Twenty-four is 1, 2, 3 2s and a 3. 32. is 8 times 4, or 16 times 2, or I think that's it. Anyway, 4 times 2, circle the 2. 2 times 2, circle the 2. 2 times 2. You end up with 5 2s. 2 times 2 times 2 times 2 times 2. What do they share in common? Well, they share 1 2, 2 2s. They share 3 2s in common. Right? So on top, I get 1 times 1 times 1 times 3. On bottom, I get 1 times 1 times 1 times 2 times 2. 4. It reduces to 3/4. A lot of you are like, well, yeah, I knew that. 8. I knew 8 went into 24 and 32, right? Because you've been doing it a long time. You've been reducing fractions probably since elementary school. Right? You've been doing it a long time. Well, the reason I did it kind of the long way is because it's going to help you later on. When we start looking at algebraic fractions, we're going to be doing the same process. Okay, so what are our steps? I wrote them on the board and they're up here. There's 2 steps. Factor or break down whatever you have. On the numerator is the top of the fraction. The denominator is the bottom of the fraction. Break it down. And then look for things that cancel out. Look for things that are shared on the top and the bottom. Okay, so let's look at example number 2. Example number 2. So the numerator, the top, is 15x. The denominator is 20x to the third power. Okay? The top and the bottom are what we call monomials. Monomials. They're just one term. So how do we break down monomials? The same way we did earlier. The same way we just did on number 1. Right? Break down 15. We just did that, right? 15 breaks down to 5 times 3. And then this one has an x. So it just times x. 5 times 3 times x. 20 breaks down a little bit more. So 20, I can go 4 times 5, circle the 5, and then I can go 2 times 2. Okay, so 20 can break down to 2 times 2 times 5, or 5 times 2 times 2. And then it's got x to the third power. That means x times x times x. Okay. Step 1 done. Broke it down. It's factor. Look for things to cancel out. 5 divided by 5 makes 1. X divided by x makes 1. So on top, I get 1 times 3 times 1. On bottom, I get 2 times 2, which is 4. X times x, x squared. Okay. Same thing. It's the same process. It's the same process we did earlier. Hasn't changed at all. Okay. So I want you to do B and C. Now do number 2, B and C. Do those on your own. So 2b, I got 90x to the second power. So 90 breaks down to 3 times 3 times 5 times 2. And then x squared is x times x. The bottom is 99. So 3 times 3 times 11. 11 can't break down any further. Look for what they have in common. They got a 3 and a 3. So the numerator, the top, is 1 times 1 times 5 times 2 times x, which is 10x squared. The denominator, the bottom, is 1 times 1 times 11, which is just 11. That's reduced as far as it can go. Okay. Letter C. 15, we've seen 15 before. It's 5 times 3. 16, though, can be broken down. 16 is 4 times 4, 2 times 2, and 2 times 2. So it's got a bunch of 2's. And then an x. Okay. There's nothing that cancels out. I have a 5 and a 3 on top, and I have a bunch of 2's and an x on bottom. There's nothing that cancel out. That means that fraction's already reduced as far as it can go. Okay. So those are monomials. So that's how we reduce monomials. Okay. Now on the back, the ones we're going to do next are trinomials and binomials. Those are a little bit different. Okay, but we've done it before. We've done this before. Okay, so let's go to number 3. Let's look at number 3 here. Okay, I have another fraction. This one has 3 terms on top and 3 terms on the bottom. It's a trinomial, right? So the first step is factor the top and the bottom. Well, how do we factor trinomials? We've done that many, many times. We have steps, right? We have steps for those. It's right there on the board. You have the steps in your notes. We've done it many, many times. That's one of the things that we did last semester that we're going to still do this semester. Factoring trinomials. Step 1 says set equal to 0. So we'll do the top first. I'll do the top. X squared minus 7x plus 6. Can't set it equal to 0. Does the green have a GCF? Is there something I can divide them all by besides 1? No. Yeah, there's nothing there. Okay. ABC then. Okay, so let me just do ABC. Okay. So I'm looking for the 2 numbers that multiply to be 6 and add to be -7. -6 and -1. So we get -6x, -1x, and +6. We've done this many, 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 many times. This part is review from last semester. So we get x times x, I get -6 and -1. So I get x minus 6 and x minus 1. That's factored as far as it can go. Okay. The bottom is also a trinomial. I'm going to do the same thing for the bottom. So the bottom, A is 1, B is -5, C is +4. So 4 and -5, I get -4 and -1. Okay, so I went a little fast because we've done this before. We've done this many, many times. You guys have done this part many times. Okay, so I factored the top, factored the bottom. Step 1 is done. They were trinomials, so that I used the steps for trinomials. Step 2, cancel out anything that's the same on top and same on bottom. So they're both binomials now. Now I have a bunch of binomials. Are any binomials exactly the same? those two guys, right? X minus 1 and x minus 1. So now it's x minus 6 times 1, which is just itself. X minus 4 times 1, which is just itself. Anything times 1 is just going to be itself. Those aren't the same. They're close, but they're not the same. So I have to cancel them out. Okay. All right, so I want you to do number 3B now. 3B now. Do that one on your own. So the top was a trinomial, the bottom is a trinomial. So these are the steps, same steps I used in the last problem. So the numerator is x plus 5, x minus 2. The denominator is x plus 1, x minus 2. They both share an x minus 2. Both of those binomials are shared. So we get x plus 5 over x plus 1. Okay, they're close, but they're not the same. All right. Okay, so letter C now. Letter C. They're both trinomials. But what do you notice about both trinomials that's different than the ones we've seen before? They both have what? They both have step 2. They both have step 2. We didn't need to do step 2, factor out a GCF. Now we're going to. That's what we're going to do first. So the GCF for the green is x. They all share x in common. So x, when I take out an x, a power of x, I get that. X squared minus x minus 4, 42. The yellow, their GCF is 2. So I divided all these by x, divided all these by 2. So 2 is the GCF. Then I get x squared minus 10x plus 21. Okay. From there, we just go on to the next step, ABC. Do the next step. Okay, we just needed to do step 2. Sometimes you'll need to do that, sometimes you won't. Okay, so the top, A is 1, B is negative 1, C is negative 42. Okay. The two numbers that multiply to be negative 42 add to be negative 1, negative 7, and positive 6. So we get x minus 7 and x plus 6. GCF always stays in front. We always write our GCF just like in front, just like we did last semester. That hasn't changed. Now I'm going to do the same thing in the bottom.
So when I factor the bottom, I get x minus 7 and x minus 3 with the 2 that was already there. The 2 is the GCF, so I need to keep that there. Okay. So now the top and the bottom are fully factored. They were trinomials, and I factored it all the way. Okay, so now I'm ready for step 2. I can't do step 2 until I finish step 1. So now I have an x minus 7 and an x minus 7. And that's about it. So on top, I have x and x plus 6 and 2 and x minus 3. Here's a question I'm going to ask you. I asked my last class. This is my finished answer, right? Can I do this? Oops. Cancel those guys out. They're both x's. Yeah, the answer is no, I can't. Why not? Close. The way I did it there is how I cancel out monomials, what I do in the front, right? Are these two monomials? No, they're binomials, right? Binomials. So I could do that if they were monomials, like I did in the front, but they're not. They're binomials. So they have to be exactly the same to do that. That's why I can't do it. Okay. All right, so last couple. It's essentially the same thing. I'm just going to be throwing in binomials now. We haven't done any binomials. Now there's going to be some binomials. Okay. So the top is a trinomial. Bottom's a binomial. Okay. So factor the top. Factor the top like a trinomial, like you've done before. Okay, so when you factor the top, what do you get? I think you get x minus 7 and x minus 4. Okay. The bottom is a binomial, so we can't use the steps. Well, we have binomial steps. It has less steps, right? For a binomial, the first thing you got to do is GCF. This guy has a GCF. The top didn't, but this guy has a GCF. I can divide both of them by, looks like, yeah, x squared. I can divide both of them by x squared. So x squared is the GCF. So when I take away 2 powers, I get x minus 4. And then the last step for factoring binomials is difference of squares. That one's close. This guy right here is close to being a difference of squares. Same thing with this guy too. If they had squareds there, they would be difference of squares, but they don't, so they're not. Okay, so those are step 1 is done, fully factored. Now, this binomial and this binomial match. So I can cancel those guys out. So I have x minus 7 and then x squared, just x squared on the bottom. No more binomial on the bottom, just a monomial on the bottom. That's all that's left. Okay. All right, two more. Two more will be done. Uh-huh. Uh-huh. Okay, so 4b. We have a binomial on top, a trinomial on the bottom. I know how to do the bottom trinomial. We've done that before. Top is a binomial. So first step, GCF. Is there a GCF to the green, to the top? No, no GCF, besides one. Is it difference of squares? Yeah, this one actually is difference of squares because it has a squared, it has a minus, and 25 is a perfect square. 25 is on my list of perfect squares because it's 5 times 5. So this will factor to x plus 5 and x minus 5. Okay. The bottom is just a trinomial. You're going to factor it like you do any other trinomials. GCF, ABC, so on and so forth. So let's see. 1, -7, +10. -5 and -2. X squared minus 5x minus 2x +10. So we get x minus 2 and x minus 5. Okay. X minus 5 and x minus 5. Those two binomials are exactly the same. We get x plus 5, x minus 2. Okay. All right, one more, last one. Last one we're going to do. The last one is kind of the top brings back what we did in the front, right? The top is a monomial. So we're going to factor the top like we did in the front. Like we did for example number 2. Example number 1 and number 2. 7x, we're going to break down 7 using the tree. But 7 doesn't break down, it's just 7 times 1, right? So really the top is just 7 times x. Bottom is a binomial. So I can divide it both by 7 and x because of the GCF, 7x. And that leaves x plus 7. Okay. There is some canceling, but just be careful when you cancel things out. So watch this. Can I cancel these two out? No, right? Because the top is a monomial, the bottom is a binomial. So I can't cancel those out. Can I do this? Yeah, because those are both monomials. Can I do this? Yeah, because those are both monomials. Good. So the top, what's the top going to be? Not 0. Yeah, sometimes I get some 0. There's always going to be something there because if you don't put anything, they're going to think it's 0. So it's really 1 times 1 because it's 1 times 1, so there's a 1 on top. So even though there doesn't seem like there's anything left, there always is. And then the bottom is just x plus 7. Okay, so just something you guys have been doing for a long time, reducing fractions, just algebraic fractions, that's all. Same rules, same everything. Okay, all right.